This is Shakil Ahmed. In this tutorial, we will discuss about the support vector machine, also called SVM. Vector machines are a set of supervised learning methods used for classification, regression, and also for outlier detection. It is usually preferred for high dimensional data sets, and high dimension means when number of predictors are high, larger than the number of observations in a data set, then it works like a regularization method. So you can use vector machine when you are dealing with high dimensional data and which are not linearly separable, and a relatively small data set means the number of observations are small, and you can also you want to generalize the to unseen data, and you are concerned about overfitting. So we start again with the strokes data. That is, I need to upload. I will upload the strokes data again. And then we can import the data and see first few observations. And we start with importing required packages. We need pandas, we need numpy, we need matplot library for visualization, and seaborn also for visualization. And from sklearn matrix we need classification report, confusion matrix, accuracy, and ROC curve and AUC curve. So let's start with data pre-processing. We need to check for uh, missing values in continuous or quantitative variables. We can replace them with their mean. For that, we need for column in this data frame, and data type is include numbers and columns, and within the columns we are selecting df column, and then fill NA with column means. Basically we are removing NS and computing mean, and then replacing those mean to the missing values. And similarly we are doing the same thing for object type of data types, where data is some type of characters, where we are replacing the mode by the missing values. Also, this is not a correct approach to import mode. You may also categorize the missing values separately. For example, if you have two categories 0, 1, you can name that category as 3 or 2. Then you can keep that category as a separate category in your variable. So but if there are only a few missing values, for example only 1% or less than 1%, then you can proceed with replacing them with mode, the majority mode, the majority class. And then we can run this command, and then we will uh, convert the categorical features into numeric. Just convert into 0 and 1 if there are two categories. If there are three categories, it will uh, make numerical accordingly. And then we can drop the stroke variable from x data. We make x variables, and then we make a y vector. Y is a vector and x is a matrix data frame consisting only columns with predictors, not excluding the outcome variable or response variable. So we can run this, and then from sklearn dot model selection, we import train and test to separate train and test data. We are keeping test set at for 20%. We can also convert it, for example, to 25% or 30% as much as you want to keep. And then we will run this command and then scale the feature. You need to Sometimes you need to scale the data to make it on low dimension. For example, you have a large variation in data, or there are large numbers in the data set, then you can subtract the mean from the values and then divide by their standard deviation. It will be standardized. So we can do this using this standard scalar library from sklearn preprocessing, and then standard scalar with bracket, and then the input is xtrain. So you are transforming xtrain and making it scalar, and you can do also for test set. Although you could do for x data before separating into test and training here. So I will run this and then apply a support vector machine for classification. We want to classify the strokes patients into stroke and non-strokes using the support vector machine. So we initialize a support vector machine model with kernel RBF. We are using a radial basis function as kernel. You can change the kernel to other, for example, Gaussian kernel. You can use other type of kernel functions. So I'm keeping this at radial basis function. This is a common choice, and we need to fix the C, that is a regularization parameter. You can increase it, will cause an increased bias and decreased variance, and vice versa. And then gamma, that is the scale parameter, and then uh, a random state, that is for a random selection of data points. Basically, we are going to split the data according to a predefined line on the feature space, and then we try to make groups which are more separable, which are more distant from the deadline. Deadline is a alpha plus beta x, a plus bx, just a linear line on the x1 and x2 plane if we have only two predictors. So I'm not going in much detail about the support vector machine and its theory. You can learn before using the codes. You need to know about the support vector machine in detail. So we will fit the support vector machine model fit using the two inputs, x trained scaled and y trained. We have scaled x as standardized values, and then we will predict the y values. SVM model is not defined. We need to run first this one, and then we need to run this one. Now it is working. Then we can predict support vector machine model, the predicted values. So x test we are using. So for x test we have the y predicted. So these are all almost zero values, 0, 0, 0, and you can also see as full screen. Sorry, it's not shown. So you can see full output here, but it's not showing. So that's okay. If you want to see, you can uh, copy it, and you can later print all the values. And then we make a classification report. For classification report will give uh, accuracy, precision, recall, and F1 score. This will give precision for each class, recall for each class. This is non-stroke class, this is stroke class. Non-stroke class we have 95% precision for, but for stroke class we have 0% zero precision, and for other values are as well. On 972 observations are in this class, and 50 observations are in this class. Okay, run this. This is not working. Classification report is not defined. If we run the packages for classification report, we need to run this packages. We need classification report here, and then we can run this. Now we have classification report. This is macro average and this is weighted average for these two values, and you have an accuracy of overall 95% for total 1022 individuals. And we can also see the confusion matrix, that is true positive and false. This is true negative, this is false positive, and this is false negative, this is true positive, this is true negative, false negative, sorry, false positive. So these are the values we can see. Basically, these are the actual cases. These are the actual cases, and these are the predicted cases. So you can classify accordingly. True positive, sample correctly predicted as positive, and true negative, sample correctly predicted as negative, no stroke. And false positive means they were stroke but not predicted as stroke, but they have no stroke. And these are predicted as no stroke although it has stroke. And you can see the same thing here as a confusion matrix plot as a heat map. You can do it as you have already. We have run this confusion matrix, and then you can annotation, and you can give the color mapping, and you can, we are naming the X labels and Y labels, and then now these are X ticks and Y ticks. Basically, these ticks labels. These are ticks, and these are labels. So you are giving label predicted and actual, and then this is a plot title. So these are tells the predicted values, predicted non-strokes. So these are the individuals who are predicted as non-stroke although they had stroke, and these are predicted as stroke and as stroke. So we have no true positive in this data set. So the support vector machine failed in predicting strokes as predicted as true stroke. And then we can also print the accuracy using just accuracy score for using these two inputs directly, that is 95%. We had already seen this. The proportion of correctly classified sample out of the total sample, and the imbalanced data set like stroke prediction where the number of stroke cases is much lower than non-stroke, accuracy alone can be misleading. So we need to check for other measures like precision, recall. We have already seen this. So Y score, we can see which value of the decision function was used. In support vector machine, we can also find the false positive rate, true positive rate, and thresholds for all possible values of y test and y score, and then we find the ROC, uh, receiver operating characteristic curve, and find the area under the curve. So let's see, and we can make a plot for area under the curve. We will take false positive rate on x-axis and true positive rate on y-axis, and color we are keeping dark orange color, and this is the label. And we can plot a straight line between 0 and 1 for x-axis and y-axis. This is a just 45 degrees straight line, and these are the x limits, x-axis limit. These are the y-axis limit, and these are the labels, and this is the title. And you can also set a legend. So that's all, and you can interpret the results. So first see the plot, and then we discuss the interpretation. So the closer the ROC curve is to the top left corner, the better the model performance. And AUC, area under curve of 0.5 indicates model that performs no better than a random guess. Area under the curve of 1 indicates a perfect model. The area under curve value summarizes the overall performance of the model across all possible classification thresholds. So these are the different values of false positive and true positive we get for different possible thresholds, classification thresholds. So that's all about support vector machine. We will first discuss different machine learning approaches for classification, and then we compare them using a real data set, how which method performs well. Although it depends on different type of data and nature of variables, you have the relationship between x and y in different data sets, and number of choice of hyperparameters in different models used. So we can't conclude that which this model is better and this model is not better. But we will I will just show how you can compare different models using different performance rates. Thank you.